Okay, we have a couple of grad cylinders for measuring the volume. We've got an overflow can. Notice the spout on the side. Petri dish for elevating the overflow can just enough so that the 250 milliliter beaker fits just underneath the spout. We've got an irregular object. You may also have a lump of paraffin wax or a piece of coal or quartz, some sort of a tool to help lower the object down into the overflow can slowly. Of course, our beaker, and we need some water. We're going to start by filling up the can. You're going to put your hole over the finger as we fill this up. Going to move the beaker out of the way. I'm going to set the, I'm going to take my hole off here, and I'm intentionally going to let it kind of pour onto the counter but near the sink. I do want to still leave room to put the beaker here without touching that thing. So the water's dripping out. Let me turn that a little bit so you can see that. The water is dripping out. And we're going to let it just stop dripping on its own. At that point, anything that goes in the water is going to push some water out of the hole. Even if it's the size of a pea, it's going to push out a drop of water. So that's what we want to have our beaker to catch. First thing you want to do, by the way, is make sure you find the mass of this. So while it's dry, so it's nice and dry, find the mass first, and then we'll find the volume through this method of water displacement using the overflow can. So we'll get it balanced on here, and then slowly lower this into the water. No faster than the water can leave that hole right there. We don't want it flowing over the top of the can. Once you get it in there, you want to let's try that again. All right, let's do it again. I'm going to flip this over. I think it'll give me a better opportunity to get this thing out when I need to. Okay, displacing water. Coming in at an angle so I can get this thing out. Let it finish dripping. Okay, it's done dripping, so now I can take a look at the volume. You can see here that we're at about 125 or so, so I'm going to go ahead and fill the 100 first, most of the way. And so now we want to read these two volumes. So the bottom of the meniscus here is about 31.5 milliliters, and the bottom of the meniscus here is about 92.8. So you'll add those two volumes together, and that represents the volume of our rock. Then with the density of the rock that you massed while it was dry, and the volume of the rock that we've just found out by water displacement, you can calculate the density. And then you got to clean up. So make sure you put everything away. Here's another method for determining the density of an irregular object. We've got kind of a handful of these little glass blobs, if you will. The number doesn't really matter. They're going to end up going in the graduated cylinder. And so we want to find the mass of these first while they're dry. So we use a weighing boat, put the weighing boat on there, zero the weighing boat, and then put our glass blobs on there. And we get a mass. And you record that mass. So we're going to add some water. Not too much, maybe 20 to 25 mils or so. And make sure you record the volume of 22.7. I don't think the camera will pick that up, but you want to record this to the first decimal place. Then we're going to add our glass beads here. Now as I'm adding these, I'm looking to see if I'm going to have enough room, because we're getting close to that 50 milliliter mark, and it looks like I'll just have enough room here. So there you can see it's getting up pretty high to the top. See where the volume is up here? So when we record that, we're at 46.0 with the final volume minus the initial volume. We know what the volume of the glass blobs must be. We masked them before. Density is mass over volume. We can figure out the density of the glass blobs.